Today we'll be covering the Cartesian coordinate system. Again, this should be review material. Just want to make sure everybody has the same definitions and that we are all using the same common vocabulary. So, Cartesian coordinate system. It's the way that we represent real numbers on an XY coordinate plane, where the horizontal axis is the x values and the vertical axis is the y values. The point where the x-axis and the y-axis cross is called the origin. To the right of the origin, we have positive values of x. To the left of the origin, we have negative values of x. Above the origin is positive values of y, and below the origin is negative values of y. This is not the only coordinate system that we'll be using this year. Later this year we'll be using the polar coordinate system, and I'll be introducing you to graphing complex numbers on what's called the R-001 diagram, and you will see spherical and cylindrical coordinates during our advanced material in January. Emphasis on this is real numbers. So I cannot plot complex numbers when I'm using the Cartesian coordinate system. We will have something similar to it. And every point that I represent on here, we will represent with the x-coordinate and the y-coordinate. The way we represent points is with a set of parentheses and an ordered pair where I have the x-coordinate and the y-coordinate. If I just tell you the x-coordinate and y-coordinate is just like x and y, you just need to remember that, hey, x's can be any real number, so that means it can be negative numbers. My y's also can be any real number, so they can be negative numbers. So you can't answer the question, hey, where does this point fall, unless you actually know what the value of x is and what the value of y is. Examples of points would be 3, 1, where the 3 is the x-coordinate and the 1 is the y-coordinate. Another example is -2, -4, where the -2 is the x-coordinate, so I go left 2, and then I go down 4. So you've been plotting points for several years. Also in review, the Cartesian coordinate plane is divided into 4 different half planes, and we call those half planes quadrants. We number the quadrants, starting with the upper right-hand quadrant as quadrant 1 with a Roman numeral, quadrant 2, quadrant 3, and quadrant 4. The definitions of what the quadrants are is if a point is in quadrant 1, we know that its x value is positive and its y value is positive. If it's in quadrant 2, the x value is negative and the y value is positive. Quadrant 3, x and y are both negative. And in quadrant 4, x is positive and y is negative. If I give you a point and ask you what quadrant it lies on, you just do the comparison. X is negative, y is positive, x is negative, y is positive, therefore this is in quadrant 2. If I give you a point on one of the axes, for example, the point 0, 5, which is located 0 horizontally and then 5 vertically, it does not meet any of these requirements, and we call any point that lies on one of the axes something that lies quadrantal. You will see this when we get into second semester when we talk about quadrantal angles, where if I have a line that lies on one of the axes, for example, an angle formed from this point to this point, that would be a quadrantal angle. So just remember that, hey, if I ask you what quadrant that point lies on, 0,5, it does not lie in any quadrant. Because the definition of the quadrant is when they're greater than or less than 0, not equal to 0.